Okay, now that we know the steps we're going to follow here, we can go ahead and do our first example. So we're going to try to solve the differential equation 2y double prime minus 5y prime minus 3y equal to 0. We're just going to follow these steps. The first one is we're going to assume y is equal to e to the mx. Then we know that y prime is m e to the mx, and y double prime is m squared e to the mx, just by taking derivatives of an exponential. And so if we want this to be a solution to the differential equation, we're going to have that 0 is equal to, let's see, 2 times y double prime, so 2m squared e to the mx, minus 5y prime m e to the mx, minus 3y e to the mx. And so then I said that the next step is going to be to cancel e to the mx out of the equation. And so I note that e to the mx is in each term, so I can just factor it out. Now it's going to be a recurring theme here, so I wrote it right there. So I've got 2m squared e to the mx minus 5m e to the mx minus 3. And once I've factored out that e to the mx, I sort of don't have to worry about it anymore. I could divide it through and it would go away. And so this thing that we're going to call an auxiliary equation, which basically just means a thing that you solve in order to solve your differential equation, is 0 equal to 2m squared minus 5m minus 3. And do I know how to factor that? I think I do. So I think that's going to factor it for me. And I'm going to check that real quick. 2m squared minus 6m plus m minus 3. Yeah, that's going to work. So I'm trying to solve this for m. I factored it in this way. And so I find that m is equal to 3 and m is equal to negative 1/2. That's sort of my m1 and m2. From here I said that you would find possibly n roots. So I had a second order equation. I found 2 values for m. So the general solution is y equal to c1 e to the m1x plus c2 e to the m2x. From the previous list, that's just what I told you the answer is. And so it's e to the 3x plus c2 e to the minus 1/2x. And I've solved the differential equation. The reason why we know that those m's will work is because we sort of solve for them by assuming that they'll work as solutions. So something that's important to note is that this type of problem just takes an ODE and turns it into an algebraic equation to solve. But an immediate concern would be, what if you get to this step right here and it doesn't give you 2 answers? Then you wouldn't have 2 things to plug into your general solution, and it's a second order differential equation, so you know you need 2 to get your answer. What if you don't have n roots? So we can sort of look at an example where that happens. If you try to solve y double prime minus 10y prime plus 25y equal to 0, then if we take y equal to e to the mx, y prime equal to me to the mx, and y double prime equal to e to the mx times m squared, we get that we should have 0 equal to m squared e to the mx minus 10m e to the mx plus 25 e to the mx is going to give us m squared minus 10m plus 25 e to the mx when we factor out that e to the mx. So we're trying to solve the auxiliary equation 0 equal to m squared minus 10m plus 25, which when we factor it is just m minus 5 times m minus 5. So we get m1 equals m2 equals 5. So I could write y equals c1 e to the 5x, but then I don't really know what to do right here. I couldn't do y equals c1 e to the 5x plus c2 e to the 5x because those are the same thing. I wouldn't have two even different solutions, so they certainly wouldn't be linearly independent, so they definitely don't form a fundamental solution set. So I'm not really sure what to do there. I'm going to tell you right now. What we do is we take y equal to c1 e to the 5x plus c2x e to the 5x, so that you have the solution written down, and then we'll go ahead and write that rule in the next slide. Basically what we're going to do is to handle what's called a repeated root. We're going to say if some root m sub I is repeated some number p times, then we use solutions e to the m sub I x, then x e to the m sub I x squared e to the m sub I x, and we keep going until we've sort of covered the number of roots that we lost here. So x to the p minus 1 e to the m sub I x. We'll go ahead and do another example that shows us how that works. And this is going to be one of those special rules that I mentioned when we were right here. That's 6 star. So we'll have like a list of these rules later, but I just put a little star here so you know that that's going to go on that list. So our example where we can kind of see this for more repeated roots is going to be to try and solve the differential equation y triple prime plus 3y double prime minus 4y equal to 0. So if I take y equal to e to the mx, then I have y prime is m e to the mx, y double prime is m squared e to the mx, and y triple prime, I think this might be our first third order equation we're solving, is m cubed e to the mx. And so if I want this to solve my differential equation, I'm going to need 0 equal to m cubed e to the mx plus 3m squared e to the mx minus 4 e to the mx. So that's going to give me m cubed plus 3m squared minus 4 times e to the mx. So my auxiliary equation is 0 equal to m cubed plus 3m squared minus 4. And I don't expect you to be able to like factor on the fly cubic equations. Like you should be happy handling quadratic equations, but cubic, I'm just going to tell you, this is just going to be 0 equal to m minus 1 times m squared plus 4m plus 4, which is m minus 1 times m plus 2 squared. So we've got m is equal to 1 and minus 2 repeated twice. And so now we have the same repeated root problem, although with the neat addition that we have another root unlike the others. So we say y is equal to c1 e to the m1x, so e to the x, plus c2 e to the minus 2x. And then I have to keep going until I have enough to fill up my solution. Or I have to keep going until I've used minus 2 times because it was repeated twice. Or I have to go until it is using x to the p minus 1 power for p equals 2, so x to the 1 power. So just cx e to the minus 2x. That's my general solution, and that is how you handle repeated roots. So in the next video, we'll do some more examples.